Okay, so what you have done is you create a predefined cluster or a CAN cluster that you can use to build the environment with GitOps. So you go to the Cloud Pak Bringer production deployment guides and you go to the production config consideration here. We have a section that we call it the golden topology. What we have here is kind of the general help on how the cluster should be set up, right? We use kind of the similar configuration when we deploy the cluster in rocks using that tile and text zone. So here in the overview in the golden topology, we walk you through of what is needed and the structure of an OpenShift cluster that is production ready. I will show you kind of the step-by-step configuration. You can read that in this page on the Cloud Pak production deployment guide. But assume you will create a cluster in the cloud region, right? You initially has an empty region. The region to support a production level, you need a high availability. So you would want to set it up on multiple availability zones. And for the cloud to OpenShift to run, you need some external services, right? This one, we need something like the DNS. You need to be able to address things in DNS because OpenShift cluster relies heavily on DNS to get to the API endpoint, to the application endpoint, and all the configuration in there is relying on the DNS. Another thing that are needed is an Ntp server, because if the time on the nodes are not coordinated, then you will see strange result on the certificate, on the time to live of the packages and all the other things. And you need a DHCP server for the node to be provisioned automatically. Another thing that you would need is a registry. The registry can be a local if you run an unrestricted network, while you mirror the images from the OpenShift quay.io and registry.redhat.com, or it can be directly from the internet and you get it from quay.io and so on. The first thing that you will create is you create a control plane, and the control plane is typically spread out in different availability zones, and you have them anti-affinity so that they will be spread out and more fault tolerant. With the control plane, you have two load balancers, the API and API internal. The API internal is used to provision new nodes, and that should be protected only to be available within the VPC, right? Because it contains a certificate to access the overall kube admin level. Then you will have the worker nodes being created, which is you have the workers also on a spread out across the availability zone. And initially, the worker will have a load balancer connected to it. Now, when you go ahead and deploy this environment, you have a running cluster now. But what we recommend is you create what we call the infrastructure nodes, and then we can remove the load balancer for the worker, and the load balancer will go through the infrastructure node. The infrastructure node contains the monitoring, logging, routing, and registry pods, which allows you to consolidate the infrastructure level access so that it would not be bothering the other workload of your application. And in the last part is the storage piece, which you will need an OpenShift container storage to serve some more advanced function like doing data replication and also doing a high availability of your PVC and also doing snapshot and other things. Okay, so this is kind of the general picture of the production level golden topology that we refer in this page. So you can read all those descriptions in this page and all the way up until the actual configuration of the nodes. Okay. Now here we also have several other pages that explain how to work with ARO, how the ARO topology looks like, how you work with ROSA, and how the topology works. And for the unmanaged one, like in AWS or Azure, we describe on the structure of that. And if we go to the tutorials, I think in the managed cluster, we have on how you would work with rocks, the configuration that you are deploying today. And we have some more advanced version of how you configure the cluster. For rocks, for ROSA, for ARO, and for unmanaged cluster, we have the Azure and AWS. And you have the scenario if you want to have a different node size, want to have a private endpoint, you want to have your own resource group and other things. So there are several other scenarios that we provide in the guide. And for the next set, I will refer to Noel.
All right, thank you, Budi. I'm going to talk a little bit about the work that we're doing around air gap in particular. One of the biggest challenges that we have out there is how to work on restricted networks like air gap environments or proxies, right? So we build out some documentation that walks you through not only deploying your cloud pack, your OpenShift cluster, but also how to get your cloud packs out there up and running. And instead of just going through everything in here, which we've tried to make it as detailed as possible, but again, work in progress, and we accept PRs if you feel that there's anything missing. I wanted to walk you through some architecture that we were doing, architectural work, on how to deploy an air gap cluster relatively quick. We're talking about hours instead of days, which is always a good thing when you're in front of a customer. So it all starts with your preferred region, right? It could be IBM, Azure, AWS, or even vSphere. So first thing we do is we define in our cloud region a VPC or a VNet. And in the VPC or VNet, we have a Bastion subnet, we have a registry subnet. And in here, we have a couple of rules that we accept traffic. So the Bastion subnet is able to get to the registry subnet on SSH and port 443, and nothing else. And by the way, this automation is written in Terraform and Ansible. We're trying to do all the infrastructure provisioning with Terraform and the configuration management with Ansible as much as possible. So wherever you see this icon, this is something driven by Terraform. Whenever you see the Ansible icon, it's Ansible, right? So the next thing we do is we deploy a couple of VMs. And we have a Bastion host that's connected to the internet. And we have a registry VM that's completely separated. The only way to get to it is from this Bastion host, right? In here, we run an Ansible playbook that will download all the components needed to create a registry server in this registry VM. Right now, we're using Harbor as the preferred solution. It's a CNCF-backed solution, but doing something with Artifactory or Quay is in the works as well, and it's a matter of creating an Ansible role for deployment. We're doing a lot of work with Ansible roles so that we can have a really nice collection of items that we can, and we're partnering with Red Hat to create all these assets as well. So now that we have everything that's needed to deploy Harbor in this case into the registry, this might be you might have, the first time I ran this was around 800 gigs. And while you could do SCP, it took like 10 hours, and that's not really feasible when you're out in the field. So we use the cloud provider APIs and do a snapshot replication of this registry VM or this registry disk this bastion disk into the registry VM. And once we have that ready, we deploy an image registry using Ansible. So we deploy Harbor, we create SSL certificates signed by a custom CA. We deploy Chart Museum in here as well. A lot of our automation depends on Helm charts. So we have a way for you to store your Helm charts in an air-gapped environment. And we also deploy Trivy, which is an image scanner, so that your customers at least get a sense of what's out there with what your image security looks like. We're trying to make this as production-like as possible. So in a production-like environment, your customers will always scan the images before actually letting you deploy them, right? So once we have all this infrastructure ready, the next step is to do the replication of the registries, right? So this Bastion host will go out to Quay.io, Red Hat, our Cloud Paks, and whatever other Docker or any other registry you want to pull from. And we'll mirror a couple of things for you. We'll do the whole OpenShift platform, whatever version you specify. We'll do OpenShift container storage because most of our Cloud Paks need a read-write-many solution, so we have to have that in there. We'll mirror pipelines and GitOps operators, as well as any Cloud Pak that you specify, and we're using the IBM Cloud CTL case bundle process for this. So at this point, from my experience out in the field doing this usually might take you 3 or 4 days just to get everything up and ready. This takes about maybe 3 hours. So we're trying to make this easy for you guys out there. Now, most of our customers don't have this, so this might be a good scenario for Tech Zone for when you want to practice this out there. But in a real production environment, you'll have a pre-existing infrastructure, right? And your customers will demand that you deploy into their specific VNet and use whatever policies they have in place. And this pre-existing VNet may be connected to their on-prem environment. And they might have a GitHub environment in there. They might have a Vault environment in there, Ansible Vault or HashiCorp Vault or whatever. So we've considered all these things. And the next thing we do, assuming that you're in something like Tech Zone or if you're deploying something like this, is we do some VPN, some Vpc Pairing so that these two networks can talk between each other. This could be an automated process. This could be something that the customer does manually. Everything that you see here is we built it as modular as possible so you can specify which things are done by automation and which things are done manually, right? And once we have this ready, we deploy OpenShift. So when you deploy OpenShift here, it'll pull from the registry and you get everything out there. It's driven by an Ansible playbook. And the next thing we do is we deploy our Cloud Paks. Again, it pulls from this registry. So let me pause for a second here and see what questions we have in here. So when the Bastion host cannot connect to the internet, that scenario is a little bit trickier, and we do have automation in here that splits the process, right? You would connect your VM, your laptop to the internet somehow, and then you pull down everything. And then you would move your laptop into the network environment and then push out to the registry. So that's still a work in progress and process, but the whole point is just to get a experience for everyone, that you can get some experience out there on how to work with air-gapped environments and how to deploy everything, right? So with that, this is what we have right now for an air-gapped environment. Again, yes, it's not truly air-gapped because this guy can get out, but this guy can't. And this is the registry, and this is really what you want. So if the registry lives here, you could also have an environment, or you could adapt this code so that you replicate into this environment in here. All right. So with that, let's talk a little bit more about some other automation that we have. And this is what Roland referred to earlier about 0 to GitOps. So we have a cluster in here that's been already pre-deployed because, again, we don't want to wait 30 minutes for a cluster to deploy, but it's a fresh cluster, nothing in here. And we're going to push some of the automation we've built. Again, as you can see, this is built with Terraform and Ansible. So, and what we're going to do is this whole process that you did manually, we're going to automate that real quick. So if you see in here, we have our demo Texas cluster 1, which is, I followed the same process to create it. I created a personal access token, and I did all that manually ahead of time. In here, what we're going to do is we're going to run a Terraform script. Let me first check OCGet nodes and just validate that I can get to the cluster, right? So as you can see, there's a pretty vanilla cluster. There's nothing in here. And what we're going to run is some automation that will get my cluster GitOps ready. So this is an Azure cluster, by the way. I think someone asked before. We're going to run pretty much the exact automation that TechZone runs for you, but in this case, it's an Ansible playbook that we're just going to deploy against our node. So let's make sure that we take a look at what we're going to create before we actually create it. So it's going to fork all the repos into all the Cloud Native Toolkit repos in here into the TechZone, into this org. It's going to clone them into my laptop, and then it's going to run a couple of playbooks to get everything up and running. So let's kick that off. And we're going to do it with cluster 1. Before I do that, Terraform workspace cluster 1. And now let's deploy this. And as we deploy that in here, the first thing you'll see is that it's forking all these repos into my fresh org. So as I refresh, we'll see that a couple of orgs have already been created. Once those repos are created, it's going to fork them locally, and then it's going to connect to the cluster and start deploying things into the cluster. So as we see here, and I'm going to switch to another cluster once we get some things shown in here, it's going to start deploying OpenShift pipelines. It's going to start deploying the GitOps operator. And we'll come back to the cluster, to this cluster in particular later if we have time. But what I wanted to show for the time being while this cooks, because we're in a cooking show, is I already have a cluster. The cluster that you were looking for here, it's cluster 1. I have a cluster here already, cluster 2, which has everything defined, but there's nothing in there. And we are driving everything to Argo CD, and we see here that we have a couple of Argo CD applications already deployed. So what we're going to do is we're going to make a change to this cluster driven solely through GitOps. So think of me, I'm the infrastructure guy. So I want to deploy certain things in my cluster, right? We have a couple of options of what we can do. And if you're in a GitHub's repo and you press the dot, just the dot character on your keyboard, you'll go into a web editor. And in here, you can actually go in and modify your files and push them out directly. So in this case, I'm going to add this nice banner that you see in here, because that's like the GitOps, Carlos, what is it that you call it? GitOps Hello World. And we're going to deploy a couple of namespaces that Carlos and Holmes will be using later. So we're going to deploy our CI environment, dev staging prod. We're going to deploy our sealed secrets, the tools operator, the tools namespace, and we're also going to deploy OpenShift container storage. So the important part in here that I want you guys to take away is that you can use GitOps not just for your application, you can actually use it for your infrastructure as well. And since we are doing the console notification, by default you get something that's like greenish and says cluster description. We're going to change it to red and make this say TechFest Cluster 2. So we have all our changes in here. We go into here, we can see the changes that we've done. And this is one of the cool things about what we're doing in here. You can actually see visually what you're going to change before you do it. In here, we see we're modifying the color and the description. So we're going to deploy infrastructure. And we're going to check that into Git. And as we check that into Git, if we go into Argo CD, you'll see that the infrastructure project is now, Argo has detected that it's out of sync. And it's going to grab all these things that I told it to deploy, like namespaces, machine sets, tools, the console notification. And if you come back in here now, you can see that it actually did something to your cluster. And this is why we like using this hello world, because it happens really fast. I'm going to skip to a cluster because we're actually deploying machine sets in here. And this takes about 10 minutes, but we don't have much time, or maybe we do. But it's going to go through everything. It's going to provision machines against Azure, and eventually you'll get all your nodes in here, as well as OpenShift container storage and everything else. But in here, we have the final product. This is cluster 3, and we've done the same things we've done over there. And you see that we have OpenShift container storage deployed. We have GitOps and pipelines ready. When you go over to your compute, you can see that we deployed all these machine sets for you. We deployed all these nodes or all these machines to make up these nodes, and you can see that we tagged them for you. We do all the heavy lifting for you. We do all the labels, everything else, so that you just have to worry about your application, not anything else. And in storage, you can see that we actually have, this is what comes out of the box with Azure. You can see that we have now a read-write-many class. This is your read-write-once class, which we make the default on purpose. And then you have your object storage as well. And you can see in here all the operators that have been deployed. So at this point, this would be a good point where I would hand it over to my application or services guy, which in this case would be Carlos. So Carlos, please take it away.